Hello everyone, welcome back to the channel. I hope you guys are doing amazing. In this video, I will show you two approaches to solve the problem, starting from the brute force approach, which is O of n log n, and then we will go on to the O of n solution, uh, which is actually very much simple if you can just think it out. Let's try to see. Let's try to see the question first and try to understand what it exactly wants from us. Uh, Question is simple. Lexicographical numbers. Given an integer n, return all the numbers in the range 1 to n sorted in lexicographical order. You must write an algorithm that runs in O of n time and uses O of 1 extra space complexity. So if you see, if you have a number n, you need to write all the numbers from 1 to n, then they must be sorted in lexicographical order. So this means that 1 0 comes before 2. Why? Because the first number is 1, which is smaller than the first number here, which is 2. So therefore 1 0 will come before in the dictionary, right? Then 2. So that's why 1 0 is before 2. And yeah, that's how it is made. Number still 13, and you can be given 5e4 solution. So you can definitely write an O of n or O of n log n, but in the question it is asked to solve in O of n and do not use any extra space. Of course, for returning the vector, you need the extra space for that. That is allowed, but not more than that. Nothing should be more than that. Let's try to see. Let's try to see what can be the very brute force approach, and we will code out both of the solutions. Uh, so first of all, it is quite clear that if you want numbers from 1 to n, okay. So if you want to generate lexicographical numbers, so what you can do, let's say n equal to 13 as given in one of the examples. So you can just push all the numbers in a vector of strings, right? You can push all the numbers in a vector of strings, and when you sort the string, they will automatically get arranged in the lexicographical order. So it's something like you store all these numbers in a string, and this where each of the number is a string, okay? And you just sort them, then automatically this one, and after that 1 0 will come, then after that 1 1 will come, 1 2 will come, 1 3 will come. Then you will get numbers like 2 3 and so on till 9, okay? So this approach is quite simple and it's brute force. Since you are sorting, you need an O of n log n, okay? uh, we can just quickly try to code that out. Uh, if you have already done it, you can skip this portion of the video just. So let's just see quickly. Mm. If you have something vector like this and you want a loop which goes from 1 to n, and you just push vector dot push back, and you are just doing two string, okay? Two string of I. And you what you do is you sort them. Sorting them automatically arrange them in lexicographical order. If you don't know this, I just told you. uh, Vec dot end. And now what will be there is that you can simply convert it into a vector of integer, which will be our final answer. uh, so what you can do, you just iterate once again in the elements of this vector this time. So the indices will go from 0 to n minus 1, and you just do answer dot push back. You extract this number, and but it is a string, so you need to convert it to integer. So string to integer, there is this function in C++, you can use that. It's quite simple to do, and you just return this answer, okay? You just return this answer. uh See if it works. Yeah, it will work, I guess, definitely, unless some syntax error is there. So you see the accepted. Let's try to submit it. Okay, so you see that runtime and space complexity is really poor. It's only 13%. So let's try to think of an ON approach. How can you solve it in ON? Okay. So this might be some non-trivial stuff for you uh, if you are not just looking at enough examples. So what do I mean by examples? let's take a large number and try to see what will happen. So let's say I need to write all the numbers from 1 to n, where n is equal to something like 5702. Okay. I'm just taking this as an example. So what should I do? What should I do at first? You see, after 1, you can see here 10 comes, right? So why does 10 comes? Because if you see, this is the number starting with 1. So the another number which also starts with 1, but it has no weight. I mean, after that it is just 0. So that this is the immediate next lexicographical number which you can get. This is the immediate next lexicographical number which you can get. Okay. So now if I tell you which is lexicographically larger, something like 100 or something like 11, then 11 is lexicographically larger, right? So 100 will come here first. Why? Because you do understand, because the first number is same, it's a tie. The second number is 1 here. So this is larger, right? So I think you understand this clearly. So that's why it's 10. And then again 100, because from 10 to 100, we can just keep adding a 0. And then again, we can go till 1000. But we cannot go 10,000 because it will exceed this 5,000. So what you can do, you can start from a number n, you keep pushing back in a vector, and you will multiply n. If you can, you will just multiply it by 10. If you can, in the sense, if it's not exceeding n, you can just multiply it by 10. Okay. Now that's what you can do. And now what else? Now what else? The next number, if you see, lexicographically smallest should be 1001, right? Because if I tell you something like 101 and 1001, which is lexicographically smaller, or even 11, this is the largest lexicographical order, because the second number is only the greatest here. And here and in these two options, the first number and second numbers got tied up, and the third number is the greatest here. So this is more lexicographically larger than this. Okay, so then 1001 will be the next case. So if you just try to blindly write it in order, you will see 1001, then 1002, okay, and then till 1009 you will write this again. Now what you will do? Can you write 1010? Can you write this? You will think that if you can write this, then where did 101 go? It should come before 1010, right? So whenever you reach 9, or you reach a number which is less, which has a leading 0, you just peel off all the leading zeros. Okay, you just peel off all the leading zeros, and then write the number, and then go to the next number. Okay, so what do I mean by it? If you are getting something like 1010, you see, okay, there is a 0 here. I will just peel it up and write 101, 101. Then again, this is the primary thing in the starting of every loop. In the starting of the loop, I will just see that if I can multiply by 10, I will just multiply. So next number will again be 101. Okay. And now, if can I multiply anything? No. Can I add? Yeah, I can add. So I will go just this till 1019. Again, after 19, the same thing pattern will keep repeating. You cannot write 1020. You have to write 102 before. So this is how you need to follow. So guys, one question for you. If you have understood the intuition and the approach, this is all the intuition for this problem. But to make sure if you can understand this, pause the video and try to think that when will 11 come? After what number? So there should be a number. Of what is that number after which 11 will come? Okay, so pause the video and try to think this, because that's what the main intuition which is required here. So yeah, after you have thought it, let's discuss. So if you think of getting 11, okay, it is lexicographic larger than all of the above. Let's say the second digit is 0 here, the second digit is 0 here, 0 here, 0 here, 0 here. Everywhere the second digit is 0 if you see in these things which I have written. So 11 will come somewhere very later, right? So when will it be? The question is that. The answer will be when I reach something like 1099. When I reach something like 1099, what should I do there? Can I write the next number to be 1100? I cannot write that. It has two leading zeros. So what I need to do is swap off the leading zeros, and the next number will be 11. Okay. So if something like 1099 come, the next number will be 11. And then again, the next number will be 110. Then again the next number will be 111, and then this will be 1101, and so on till 1109. You understood this, right? You understood. I think you got it. This concept needs to taken care of, so that you just understand it. Like, this is the main intuition behind it. So 1099, after 1099 only there will be 11 coming. So if you try to code this out, it will be really simple. You just need a loop which is traversing n. So first you take an integer x, you start it from 1, uh, to have a vector integer answer, and I will directly push stuffs into this vector. uh, I will make sure I iterate not more than n times, so just to take care of that. Whenever I am first in the loop, I will just do answer dot pushback. So initially I have 1, I will just answer dot pushback 1 x. Okay, this x value I'm going to push back. Now, what to do? If I am saying that if I can multiply a 10 with the number, that is our first priority, right? If I can multiply a 10 with the number, okay, and still my number is less than equals to n, number is not exceeding this, then what will I do? I will do x into equal to 10, and I will continue. Continue means don't see what's next in the loop. You just go on with the next iteration. So if 1 is there, it multiplies and gets 10, and then it goes to the next iteration and do answer dot pushback 10. So you get that. Okay. I think you get that. Now what I told you here, if there is nothing, if there is nothing, you just need to add 1, right? If there is nothing, you just keep adding 1. So you just do answer plus plus. Let's try to see this and check what happens uh, on doing this. Okay. Now, if you have something like 100 and 1009 or 1099, and if you are adding 1 to it, you will get leading zeros, right? So while you get a while loop, while you have a leading zero, while x module 10 equals to 0, so it means that while you have a leading zero, what do? You strip off those. You strip off the leading zeros. Yeah. So now the X number, whichever you have, you don't have any leading zeros in that. You can simply go to the next iteration and do stuffs. Yeah. So if I try to return this answer, let's see if it works, because that's all we thought, right? Am I missing something? Okay. So you see, uh, there is some error. There is some error. Okay. What is the error? So you see, the number n is still 13. So I did not put any check which will stop it after 13, right? After 13, it will go on till 14, because 14 is the next lexicographical number after 13, not 2. So it goes 14, but I need to check that whether that number is present or not. Before incrementing, I will keep a check that if x plus 1, if this x plus 1 is exceeding n, then what you need to do? So let's say in this case you got 13, right? So in that case 13, you just strip off this 3, and you will remain with 1, and you just go on incrementing 1, 2, 3. So similarly, as when you reach here something like 5072 already, okay, and when you are seeing that if I increment this, I will exceed this number, you just strip off this number. Next number will be 570, 571, and things will go on that way. And you can clearly see that 571, you cannot multiply it by 10, because that will exceed this number. So that is already taken care of in this check, okay, in the first check. So if my number is exceeding n, adding 1 exceeding n, just strip off the last digit. Strip off the last digit. Do a modulo, not modulo, floor division, and strip off the last digit. Now let us check if it works. So see, we have a very neat accepted. Let's try to submit it and check. So see, we do have the accepted thing. Our runtime complexity is really great. Our memory is great. So yeah, that's all. Uh, so so yes, this was right simple, right? If you think of this intuition, it's quite simple to do. I mean, it's simple to code this out, right? So that's all. That will be all for this video. So just a check, if you have reached till the end of this video, you can just write yo bro in the comments. So yesterday I also told people to do this. So I will tell you there were only 2 comments. So uh, it motivates me, right? But also it checks that how many such serious aspirants are there who are actually preparing for top companies very really seriously and have the patience to learn, have the patience to understand stuff. So yeah, I got only 2 comments yesterday. So let's check this time. Yeah, this is maybe a very common question. So maybe you will get some videos which have already been made on this topic. Since this is a very old question, the question number you see it's 386. So yeah, if you do get my view and you do reach this point, you can definitely comment the timestamp if you did not understand any portion of the video, and if you understood everything, and if you reach the end of the video, you are comfortable with everything, you just comment that in the comment section. Yeah. So that's all for this problem. I hope this was a medium kind of problem if you could come out with this ON approach, but I hope your day would be really easy. Thank you so much.